In the last 48 hours, what we feared and expected at the same time has happened. Tri-Eye Atlas has entered a critical phase of its journey through our solar system. What we are witnessing now could be a turning point, not only for this particular object, but also for our understanding of what is possible in space. We are at the point of no return. In 27 hours and 30 minutes, on October 29th at 11:30 a.m., Moscow time, 3A Atlas will reach its perihelion, the closest point to our Sun. The distance will be 1.36 astronomical units, 204 million kilometers. This is closer than Mars's orbit, but still far enough away that it does not pose a direct threat to the inner planets. But it's not about safety. It's about what's happening to the object itself. And what we've been observing over the last 2 days is forcing the astronomical community to rethink everything we thought we knew about interstellar visitors. Let's start with the main thing. The brightness of 3I Atlas has increased by another 2.5 magnitudes over the last 48 hours. For non-professionals, this means that the object has become almost 10 times brighter. Its current magnitude is 9.8, which means that it is at the limit of visibility to the naked eye under ideal viewing conditions. But the problem is not that it has become brighter. The problem is the speed of this change. Mathematical models predicted a gradual increase in brightness as it approached the Sun. Instead, we are seeing exponential growth that does not fit into any existing theory of cometary activity. Dr. Sarah Collins of NASA's Jet Propulsion Laboratory, who heads the Tri-Eye Atlas observation program, called an emergency press conference yesterday. Her words sounded like a death sentence for our old ideas. What we are observing does not correspond to any computer model. The object is behaving as if it has an internal energy source that activates as it approaches the Sun. Over the past 48 hours, the size of the Coma, the gas and dust cloud surrounding the nucleus, has increased from 900,000 kilometers to 1.2 million kilometers. That's larger than the diameter of the Sun. A small nucleus just over 10 kilometers in size is creating a structure around itself that exceeds the size of our star. But even more striking is the change in the chemical composition of the ejected material. Spectral observations made by the James Webb Telescope in continuous monitoring mode show the appearance of new spectral lines. Molecules that were not present even a week ago are now present in significant concentrations. Among the new components are complex hydrocarbons that should not form in the cold and vacuum of space. Acetylene, ethylene, even traces of benzene are organic compounds typical of industrial chemistry, but impossible for natural cosmic processes at such temperatures. Professor David Levison of the Southwest Research Institute, one of the leading experts on the dynamics of small bodies in the solar system, does not hide his confusion. In 30 years of studying comets, I have never seen anything like this. This is not just a new type of cometary activity. It is something fundamentally different. Temperature measurements add even more mystery. Infrared observations show that the surface of the Tri-Eye Atlas nucleus is unevenly heated. There are areas with a temperature of -70 degrees Celsius, which is normal for an object at such a distance from the Sun. But there are also areas with temperatures up to +20 degrees. 20 degrees Celsius. At a distance of more than 200 million kilometers from the Sun, where even during the day on Mars, the temperature rarely rises above -20 degrees Celsius. Where does this heat come from? There are practically no natural explanations for this phenomenon. The radioactive decay of long-lived isotopes could provide some internal heat, but not on such a scale. The observed heating would require concentrations of radioactive elements that are incompatible with the natural origin of the object. Tidal forces from the sun's gravity also cannot explain such heating. At the distance of perihelion, these forces are not strong enough to cause significant deformation of the solid core. In addition, the temperature anomalies began long before the maximum approach. This leaves us to assume the presence of active processes inside the object. Chemical reactions that release energy under certain conditions. Or, even more intriguingly, technological systems that activate as the object approaches the star. Analysis of the polarization of radiation provides additional cause for concern. Light reflected from the surface of Tri-I Atlas shows a polarization degree of 70%. This is characteristic of reflection from metal surfaces with a high degree of orderliness. In natural comets, polarization rarely exceeds 10 to 15% due to the chaotic structure of the surface. High polarization indicates either crystalline structures or artificial materials with a regular molecular lattice. Dr. Maria Gomez of the European Southern Observatory, who led the polarization measurements, stated bluntly, "I have only seen such polarization values when a laser beam is reflected from a polished metal surface. Natural objects do not produce such results. High-resolution radar studies have revealed even more striking details. The surface of Tri-A Atlas is covered with geometrically regular structures. Ridges, depressions, and protrusions form a complex but orderly pattern. Computer analysis of these structures has revealed periodic patterns with characteristic dimensions ranging from 10 to 100 meters. Natural processes of erosion and accretion cannot create such geometric regularity. It is more reminiscent of technological structures, antenna arrays, heat exchangers, or even solar panels." Professor Thomas Anderson of the Massachusetts Institute of Technology, who specializes in the analysis of radar images, does not hide his surprise. "If I had been shown this data without knowing the source, I would have said that these were images of an artificial satellite. Nature does not create such regular geometric shapes. Magnetic measurements add another layer of mystery. Over the past 48 hours, the intensity of the magnetic field around Tri-I Atlas has tripled. It now measures 5 microtesla at a distance of 10,000 kilometers from the object, which is comparable to the magnetic field of large asteroids such as Vesta or Ceres. But Tri-A Atlas is 100 times smaller than these objects. To create such a field, either a core of almost pure iron or active electromagnetic systems would be required. The first option contradicts all observational data on the composition of the object. That leaves the second option. Dr. Elena Vasilyeva from the Institute of Earth Magnetism of the Russian Academy of Sciences commented on the situation as follows. "The observed magnetic field cannot be of natural origin. Its structure and dynamics indicate the presence of controlled electromagnetic systems inside the object. The spectral evolution of 3A Atlas over the past 2 days presents a separate mystery. In addition to the appearance of new organic molecules, we are observing changes in the intensity of already known spectral lines. Some are getting stronger, others are getting weaker, and still others are disappearing completely. Such dynamics are characteristic of controlled chemical processes rather than chaotic degassing. It is as if someone or something inside the object is regulating the release of various substances depending on external conditions. Particularly intriguing is the appearance of spectral lines of xenon, an inert gas that is extremely rare in comets. On Earth, xenon is used in ion engines of spacecraft due to its unique properties. Its presence in 3H Atlas may indicate the technological origin of the object. Professor John Wright of the University of Pennsylvania, a renowned expert in the search for technosignatures of extraterrestrial civilizations, stated bluntly, "The combination of observed anomalies makes the hypothesis of Tri-I Atlas's artificial origin quite plausible. We may be dealing with the technological artifact of an extraterrestrial civilization." The object's behavior over the last 48 hours also raises questions. In addition to the already recorded trajectory corrections, a change in rotation speed has been observed. The rotation period has decreased from 20 hours to 18 hours and 30 minutes. In natural objects, changes in rotation occur slowly, under the influence of tidal forces or the reactive effect of gas emissions. But the observed changes are too rapid and too regular for natural processes. It seems that the object is actively controlling its rotation, possibly to optimize its orientation relative to the Sun. Such behavior would be logical for a spacecraft with solar panels or other directional systems. Gravimetric anomalies have also intensified. Analysis of the trajectories of passing space probes shows changes in the distribution of mass within the object. The center of gravity shifts with a periodicity that coincides with the cycles of activity. Such changes could be the result of the movement of liquids or gases inside the object. But for a natural comet, the volumes of internal cavities must be insignificant. The observed effects indicate the presence of large internal chambers or reservoirs. Acoustic studies conducted by analyzing seismic vibrations during gas emissions have revealed resonance frequencies characteristic of hollow structures. The internal architecture of 3A Atlas is more reminiscent of an artificial structure than the monolithic stone and ice core of a comet. Dr. Kevin O'Connor of the Johns Hopkins University Applied Physics Laboratory, who specializes in analyzing the internal structure of space objects, commented on the situation. The resonance characteristics indicate a complex internal architecture with multiple cavities and chambers. This is not consistent with the natural origin of the object. The electrical properties of 3I Atlas have also undergone changes. Interaction with the solar wind shows an abnormally low electrical charge on the surface. Comets typically accumulate a significant static charge when exposed to charged particles from the solar wind. A low surface charge may indicate the presence of conductive paths that carry electricity into the object. In artificial spacecraft, this is standard practice to protect electronic systems from electrostatic discharges. The thermodynamic characteristics of the object also do not meet expectations. The temperature distribution across the surface is too uniform for a natural body. Comets typically exhibit sharp temperature gradients between the illuminated and shadowed sides. With 3A Atlas, these differences are smoothed out, as if internal thermoregulation systems are at work, redistributing heat throughout the volume. Such technologies are used in modern spacecraft to protect sensitive equipment. The isotopic composition of the ejected gases also evolves. The ratios of carbon, oxygen, and nitrogen isotopes change in sync with the object's activity cycles. This may indicate the selective ejection of materials with different isotopic characteristics. In natural comets, the isotopic composition remains relatively constant, reflecting the conditions of formation in the protoplanetary disk. The observed variability is more consistent with controlled processes using pre-separated materials. Professor Andrei Finenko from the Institute of Geochemistry and Analytical Chemistry of the Russian Academy of Sciences noted, "The dynamics of isotopic ratios indicate the presence of internal reservoirs with different materials that are selectively ejected depending on external conditions. This is characteristic of technological systems, not natural processes. The optical characteristics of the surface have also changed. The albedo, or reflectivity coefficient, has increased from 0.1 to 0.5 over the past 48 hours. Such a change in reflectivity may be the result of surface renewal or the activation of reflective elements. In natural comets, albedo typically decreases as they approach the Sun due to the accumulation of dark dust on the surface. The observed increase contradicts all known models of comet evolution. The structural integrity of the object also raises questions. At the observed rotation rates and internal activity, a natural comet nucleus would have begun to break apart. Centrifugal forces and internal gas pressures exceed the strength of ice and rock. But 3A Atlas maintains structural stability, indicating either exceptionally strong materials or active integrity support systems. Modern composite materials or power frames could provide the necessary strength. The hydrodynamic characteristics of the gas emissions are also unusual. Instead of the chaotic expansion in all directions characteristic of cometary degassing, we observe directed flows with a clearly defined structure. Some emissions form collimated jets, more reminiscent of jet engines than natural ice sublimation. The angle of divergence of these jets is only 5 to 10 degrees, indicating the presence of guiding structures or nozzles. Dr. Lisa Chen of the California Institute of Technology, who specializes in gas dynamics, commented, "The observed characteristics of the gas flows are incompatible with natural degassing processes. It is more reminiscent of the operation of engineering systems. The temporal correlation of various processes is also noteworthy. Changes in the magnetic field, temperature, chemical composition, and structural transformations occur synchronously with a periodicity of 73 hours. Such precise temporal organization is characteristic of controlled systems, not chaotic natural processes. Perhaps there is some kind of central controller or program inside the object that coordinates various subsystems. The energy characteristics also do not correspond to natural processes. The total power of all observed phenomena, heating, magnetic field, directed emissions, is about 10 to the 10th power watts. For comparison, the power of solar radiation falling on an object the size of the 3A Atlas at its current distance is only 10 to the 7th power watts. Where does the extra energy come from? The radioactive decay of natural isotopes could produce a maximum of 10 to the 5th power watts for an object of this size. Chemical reactions produce even less. This leaves us to assume either unknown physical processes or artificial energy sources. The object's communication characteristics are of particular interest. Radio telescopes detect weak but structured radio emissions with frequency modulation. The carrier frequency is 1.426 GHz, which is close to the frequencies used for space communications. The modulation is not random. Analysis reveals repeating patterns that may represent encoded information. If so, we may be dealing with an attempt at communication or the transmission of technical data between components of the system. Dr. Seth Shostak of the SETI Institute commented, "The structure of the radio signals indicates an artificial origin. If this is an attempt at communication, it is of historic interest to humanity. The object's navigational characteristics also continue to evolve. Over the past 48 hours, 2 more trajectory corrections have been recorded, each of about 0.05 degrees. The total deviation from the original course is now 1.2 of a degree. Such maneuvers require precise knowledge of its own trajectory and the gravitational field of the solar system. A natural object has no mechanisms for obtaining such information and making corrections. Biological aspects also deserve consideration. Among the organic molecules detected in the spectrum of Tri-I Atlas, there are compounds that are associated with biological processes on Earth. Amino acids, nucleotides, even simple proteins. Perhaps the object carries biological samples or even living organisms from another star system. Alternatively, complex organic molecules could have been synthesized artificially for some technological purpose. Professor Maria Zubova of the Institute of Biology of the Russian Academy of Sciences noted, "The organic compounds discovered include molecules that are critical to life as we know it. Their presence in an interstellar object raises fundamental questions about the spread of life in the universe. The geological characteristics, as far as they can be determined remotely, are also unusual. The mineralogical composition of the surface includes compounds rarely found in comets, titanium silicates, rare earth oxides, and even traces of artificial crystal structures. On Earth, such materials are used in high-tech devices, from superconductors to quantum computers. Their natural formation requires conditions that are unlikely to have existed in interstellar space. The atmospheric characteristics of the Coma are also evolving. In addition to traditional cometary gases, water vapor, carbon dioxide, carbon monoxide, more exotic compounds are appearing. Fluorides, borides, even traces of super-heavy elements. Some of these substances are unstable and should have decayed during interstellar travel. Their presence may indicate recent synthesis or the presence of stabilizing mechanisms. The photometric characteristics of the object demonstrate a complex temporal structure. The brightness varies not only with the rotation period, but also with additional modulations at frequencies that are multiples of the main one. Such harmonic modulations are characteristic of objects with complex shapes and periodic structures on their surface. Perhaps we are observing reflections from regularly spaced technological elements. Polarimetric measurements have revealed another anomaly. The plane of polarization of the reflected light rotates at a constant angular velocity, regardless of the orientation of the object. Such an effect can be created by active optical elements. On Earth, such devices are used in laser technology and optical communications. Their presence on an interstellar object would be direct evidence of technological origin. Seismological characteristics, determined by microvibrations during gas emissions, indicate a layered structure of the object's interior. Wave propagation speeds vary in different directions, which is characteristic of composite materials. Natural comets usually have a relatively homogeneous internal structure. The observed anisotropy is more consistent with engineered structures with directional reinforcing elements. Crystallographic data obtained from the analysis of reflected X-rays show the presence of highly ordered crystalline structures. Some of them do not occur in nature and can only be created artificially. Quasicrystals, fullerenes, even traces of graphene. All these are materials developed by Earth science in recent decades. Their presence in an object formed billions of years ago seems incredible. Dr. Alexander Petrov from the Institute of Crystallography of the Russian Academy of Sciences commented, "The crystal structures discovered could not have formed naturally in interstellar space. They are the products of high-temperature technological processes. The chemical activity of the object is also increasing. In addition to simple sublimation processes, there are signs of complex chemical reactions with the formation of new compounds. Catalytic processes, polymerization, even elements of organic synthesis. Such chemical complexity requires special conditions, controlled temperatures, pressures, and the presence of catalysts. Under the natural conditions of interstellar space, these processes are impossible. Perhaps there are chemical reactors or automated laboratories operating inside the object. Alternatively, we are observing the results of biological systems, the metabolism of living organisms adapting to new conditions. Electrochemical processes on the surface of the object also deserve attention. Interaction with the solar wind creates local electric fields that affect the distribution of charged particles in the surrounding space. The observed effects indicate the presence of conductive structures that create directional electric fields. Natural comets do not have such structures due to the low electrical conductivity of ice and rock. Magnetohydrodynamic processes in the plasma surrounding the object also show anomalies. The solar wind interacts with Tri-I Atlas not as an obstacle, but as an active source of magnetic field. Complex plasma structures are created, magnetic traps, accelerating regions, even something resembling plasma engines. Such effects are observed only in planets with strong magnetospheres or artificial spacecraft with special equipment. Gravitational anomalies are also amplified. In addition to changes in the center of mass, local perturbations of the gravitational field are observed. Some areas of the object show abnormally high density, while others show abnormally low density. Such inhomogeneities could be the result of heavy metal structures in some parts of the object and hollow chambers in others. This is more consistent with an engineered structure than a natural formation. The timing characteristics of all these processes demonstrate clear coordination. Various systems are activated and deactivated in a specific sequence, as if following a pre-programmed algorithm. Perhaps the approach to the Sun serves as a signal to activate various subsystems of the object. Each system is activated when a certain level of solar radiation or temperature is reached. Such behavior would be logical for an interstellar probe designed to study star systems in detail. various scientific instruments could be activated at different stages of the approach to maximize the amount of data collected. Alternatively, we may be observing the process of the object waking up after a long interstellar journey. The life support, communication, and navigation systems are gradually coming out of hibernation as they receive sufficient energy from the star. In any case, the coordinated nature of the observed processes practically excludes their natural origin. We are dealing either with unknown physical phenomena or with a technological artifact of an extraterrestrial civilization. The next 24 hours will be critical. The passage of perihelion should activate the maximum number of the object's systems. If our assumptions are correct, we may witness phenomena that will forever change our understanding of humanity's place in the universe. Unfortunately, at this very moment, the solar conjunction will hide 3A Atlas from Earth observers. Our last direct observations will be completed in a few hours. After that, the only witnesses to the critical events will be Martian orbital spacecraft. We are in a unique situation in human history. Perhaps for the last time, we are observing an object that may be a messenger from another civilization, or evidence of physical processes that we are unaware of. In any case, the next 48 hours will go down in history as the moment when humanity was confronted with evidence that the universe is full of phenomena beyond our wildest imagination, and that our journey to understanding the cosmos is just beginning.